Hello, and thank you for joining us. Today, we're here to talk about research efforts that we hope will improve the prevention and treatment of obesity in adults. I'm Dr. Griffin Rogers, Director of the National Institute of Diabetes and Digestive and Kidney Diseases, or NIDDK, at the National Institutes of Health. I'm joined today by my colleagues, Dr. Susan Yanowski, who is a co-director of the NIDDK's Office of Obesity Research, and Dr. Mark Reitman, who is the chief of the Diabetes, Endocrinology, and Obesity Research Branch here at NIDDK. Through our discussions, we'll be answering questions you write in to the chat. And if we don't answer your question during this live video, please check our social media feed at NIDDK.gov, where we'll continue to address your questions. Thank you for joining us today, Drs. Yanowski and Reitman.
Thanks for having me.
Yes, thank you very much.
Thanks. Well, obesity, let's get right into it. Obesity affects over 40% of adults in the United States, a trend that continues to rise. Could you start off by discussing some background on obesity and obesity research? Dr. Yanowski?
Sure. There are multiple factors that affect risk for obesity, and what we're often seeing is a result of a genetic predisposition, which many people have, interacting with our obesity-promoting environment. And factors ranging from a child's prenatal environment to diet and physical activity behaviors through things like even stress or lack of sleep. All of these can increase risk. But in addition, social determinants of health, these are the conditions in the places where people live, work, learn, and play, also impacts not only risk for obesity, but also obesity complications. And as we all know, I think obesity is a risk factor for numerous serious and chronic health conditions, including type 2 diabetes, cardiovascular disease, some forms of cancer, fatty liver disease, and osteoarthritis. And because obesity impacts almost every organ system, at the NIH, we take a coordinated approach to obesity. We have more than 20 different institutes, NIH institutes, centers, and offices working together to address obesity through our Trans-NIH Obesity Research Task Force. And even within NIDDK, we also have a coordinated approach to obesity research. As Dr. Rogers mentioned, we have an NIDDK Office of Obesity Research, and we work across the Institute with the NIH scientific staff, the external research community, and other stakeholders to identify exciting and innovative research opportunities to better understand, prevent, and treat obesity, but also to improve the lives of people affected by obesity.
Oh, that's right. And thank you, Dr. Yanowski. There's clearly extensive collaboration across NIH on obesity. Now, could you tell us more about obesity research being conducted by researchers working within NIDDK? Dr. Reitman.
Thank you. We do quite a bit of obesity-related research in NIDDK. In the Diabetes, Endocrine, and Obesity branch, we conduct basic, translational, and clinical studies to better understand, prevent, and treat diabetes, obesity, and related conditions. Animal models, often using mice, make it easier to understand the physiology, therefore facilitating more directed and studies clinically in people and with a higher probability of success. Some of the specific examples of research going on in our branch include trying to study the differences in energy metabolism between mice and humans to better inform those human studies. Other NIDDK researchers look at the brain circuits that influence eating behavior. For example, exposure of mice to a high-fat diet causes them to value their previous chow diet less. And in fact, this probably involves brain circuit changes that persist for weeks after the rewarding diet's no longer available. We also have investigators that study the function of brown adipose tissue, which is important for keeping mammals warm, although that's much more important in small mammals than humans. And the exact importance in humans is a subject of active research and discussion. For example, there's a drug that can activate brown fat called a beta-3 agonist that's being studied. We also have a very, very valuable tool, which is the NIH Clinical Center. And what that does, it allows us to actually domicile people for the duration of a study. Very small changes in food intake can be very important, and the most accurate method to know food intake is actually weigh all the food eaten. And that you can do in an inpatient setting, which you can't do in the environment. And finally, we also study rare disorders such as the lack of fat, which is not obesity, but it informs about the physiology that will apply more broadly, including to the physiology of obesity.
Well, thank you very much. In advance, we've gotten a lot of questions that are coming in. We're trying to synthesize it. And let me come up with just two that are really the most frequently asked questions. So I have one for each of you. And the first question is, what type of diet should I eat to lose weight or to improve my health? Sue, you want to take a crack at that one?
Sure. Well, as we talked about, there are multiple factors that affect obesity, ranging from genetics and diet through environment and social determinants of health. So a seemingly simple question, what should I eat to be healthy or to lose weight, isn't really simple at all, and nor is it the same for people of different ages or sizes. So NIDDK and other NIH institutes collaboratively developed the first strategic plan for NIH nutrition research to help answer these questions and many others related to nutrition and health. And this plan emphasizes innovative opportunities to advance nutrition research. So the plan calls for a multidisciplinary approach to answer questions and has five strategic goals. And one is to spur discovery and innovation through foundational research. That's basic research. What do we eat and how does it affect us? A second is looking at the role of dietary patterns and behaviors for optimal health. This is what should we eat, but also when should we eat? A third is looking at the role of nutrition across the lifespan. That is, how does what we eat promote health across our lifespan from prenatal through infancy all the way through older age? And finally, how can we reduce the burden of disease in clinical settings? That is, how can we improve the use of food as medicine?
Well, thank you. Hey, Mark, here's one for you. What are your thoughts on the keto diet?
Sure. The keto diet has a long history. The first use of the keto diet and where it gained prominence was treating kids with seizures. And it works for seizures, intractable seizures. But a few things about that diet. It's very difficult to stay on for a long term, and it really works well when you have a parent who wants their child's well-being, and so it's enforced. One hypothesis about how the keto diet works is that it may act to reduce appetite in ways we don't quite understand. Another is that you get tired of the monotonous foods and eat less. An interesting study was performed by Kevin Hole and collaborators where they compared a low-fat plant-based diet to a low-carb ketogenic animal-based diet. And they found that actually, contrary to what you might have expected, there was actually more caloric intake on the low-carb ketogenic diet. And probable contributors or possible contributors that deserve further investigation are that there was actually a higher caloric density, meaning you got more calories in per bite of food on the ketogenic diet in this case. And even though those people on the ketogenic diet ate for a less amount of time, they ended up taking more calories in those shorter meals. So the other point I'd like to make is this was done in domiciled patients, so you really know exactly how much they eat, and it was a very rigorous study. So what this study does is point out that we really need to understand things, understand the science and what is good about a ketogenic diet with further studies.
Well, thanks. So no simple answer to that question. That's for certain. Here, we've learned a lot from the landmark NIH funded diabetes prevention program study that just modest weight loss, say 5 or 7%, can result in significant and clinically important reductions of disease risk factors, such as blood pressure level and type 2 diabetes incidence and osteoarthritis pain. As we continue to research, what happens to the body weight loss? What treatments or strategies do we know work for weight loss? Sue, let me turn to you first.
Sure. A clinically meaningful weight loss, as you mentioned, generally it's considered to be 5% or more of initial body weight in adults, is achievable for many with a set of standard behavioral counseling tools like goal setting, feedback, self monitoring, social support, and problem solving. But even with the best available behavioral treatment programs, about half of people can't lose enough weight to improve their health. In addition, even when you can lose weight, sustained weight loss is difficult for many people to achieve. So, for individuals who meet certain weight or health criteria or who have difficulty losing or sustaining enough weight loss to improve their health, anti obesity medications like semaglutide or even bariatric surgery may be helpful. But in addition to intervening at the individual level, we also need environmental and community based approaches. That is, shaping policies to make the healthy choice the easy choice.
Yeah, there's some very interesting physiology that the body does not want to lose weight. Once you've dieted, your body becomes metabolically more efficient because your brain is perceiving that I'm underfed for whatever reason. There's been a change in that balance point, and therefore your appetite grows to compensate. So people who've lost weight actually have a higher hunger drive and actually become metabolically more efficient. So they have to continue eating less to maintain that weight reduced state. One of the ways to take this into account is that you can use mathematical modeling, and there's a body weight planner tool, which was referenced in the accompanying online materials. And this is a science-based technology that shows how a reduction in caloric intake will, after adaptation by the body, result in a resulting body weight. And the bottom line is that the kind of diet that you will adhere to for the indefinitely is the diet that will work. There's no one magic diet. The kind of diet that you'll feel comfortable adhering to may change over time. So the most important diet is the one where you have a lower caloric intake sustained indefinitely. Just like we wouldn't stop treating hypertension with drugs after initial success, we don't stop treating obesity after initial success with diet. It's a long-term commitment to a reduced food intake indefinitely.
Absolutely. Sue, any further comments on that, or?
Sure. There's growing recognition that weight loss and weight maintenance are really two distinct and complex processes. As Dr. Reitman pointed out, when you lose weight, things change. You may become more metabolically efficient, and your appetite increases, and your body really has a drive often to get back to its previous weight. Some people can lose and maintain weight, many others struggle. So we recently started the Physiology of the Weight Reduced State Clinical Trial Consortium, or POWERS. And POWERS is seeking to understand individual variability in maintaining weight loss after weight loss treatment. What happens with appetite? What happens with energy expenditure and energy efficiency? And so with this study, we're really hoping that we can reveal the mechanisms for each individual for why they struggle with weight maintenance after weight loss. And this may then lead to personalized treatments to help make it easier for people to maintain that weight loss.
Absolutely. And in fact, I think, both Dr. Yanowski and Dr. Reitman mentioned, really getting people on a eating plan with the understanding that this is something, particularly a healthy eating plan, that's going to be more long-term. Diet sort of connotes the idea of, conveys this idea of something that's transient. And once you've lost the weight, then everything is back to normal. And so maybe we'll have to start thinking about this a little bit differently as we think about more personalized approaches. Well, we have two other questions here. Let me toss them out. What methods are used to calculate the daily calories burned? Mark, you want to try to handle that?
Sure. So there's basically your oxygen consumption, how much oxygen you burn up is is a measure of the measure of the daily of the calories burned, and that can be measured for a few minutes by a mask or it can be measured over hours to days in a room chamber where a person lives in this chamber, and the oxygen consumption is measured. Finally, there's a longer term measure called double label water, which measures it over 2 weeks. But the caloric intake, the energy expenditure equals the caloric intake in the long term. And unfortunately, we don't have a great way of measuring caloric intake accurately, except in a domiciled person where you weigh all the food. There are some tools like a food questionnaire. There are also some tools where people try and photograph the meals they eat. But we really don't have a magic way of getting good, accurate food intake measurements, because one of the problems is that you really need to have food measured within a few percent. That 5% is a big difference in energy expenditure or food intake if maintained consistently over time. And that's one of the difficulties we have in obesity research.
Absolutely. Certainly something we need to get better tools with respect to. The other question that's frequently asked is, does obesity run in families, and what actually causes obesity? Sure.
I can take that. So obesity clearly has a very large genetic component, and there's two sort of extremes in this. One is there are very rare people who have what is called monogenic obesity, where a single gene is mutated and they get obese based on that. And that's very rare, probably a few percent of the obese of the obese people at the max. And then there's the much more common where you have hundreds of genes and thousands of DNA loci that each contribute a very, very, very small amount to the obesity. And of course, it's a continuum where there are probably some intermediate, but that's the sort of the landscape of obesity. It's a very strong genetic component, and in general, it's what we call polygenic, where many genes each contribute a small amount. But that's not to say obesity is a genetic disease, that these are just predispositions that almost uniformly can be overcome with environmental adaptation. And so the environment is also crucial. We should, again, reduce our food intake. We should have balanced diets, and we should also be physically active. And all those things together can counter some of the genetic predispositions. And just like there's genetic predisposition to obesity, the opposite of that is genetic predisposition to leanness. So all of us fall on a spectrum.
Absolutely. Thank you. I know this Facebook event is focused on adult obesity, but Sue, let me ask you, because a question has come in, what research is happening on childhood obesity?
Sure. Childhood obesity has also increased dramatically over the past few decades. And unfortunately, there's now some evidence that during the COVID pandemic, it is increasing even more, particularly in some at-risk kids who already had obesity before the pandemic, or who are some racial and ethnic minority populations. So this is really a big problem that's going to be affecting people's health for decades. And at NIDDK, we really support innovative studies to better characterize what are the early life risk factors, what are the underlying causes that contribute to the development of obesity, including during infancy and early childhood, because obviously if you can get in there early and prevent obesity from ever developing, that's what you'd really like to do. And those studies aim not only to understand biological mechanisms and metabolic risk for obesity development, but also how other contributors like psychosocial and contextual and environmental factors contribute and what can be done to lower risk. And we're actually just going to be starting a new pediatric obesity discovery initiative very shortly that's really going to be trying to get in to see what is happening prenatally or during infancy. What are some of the mechanisms that put some kids at risk? But in addition, we really need to have prevention approaches that work for many people. And one promising approach for childhood obesity prevention was tested in a study called the Intervention Nurses Start Infants Growing on Health Trajectories, or INSIGHT studies, which also had a follow-up study. This looked at a home-delivered intervention. It was delivered by nurses at home to help first-time mothers prevent childhood obesity through developing skills in what's called responsive parenting, becoming more aware of their child's cues when they're really hungry or sleepy, or just need something other than food. And this strategy was actually shown to lower the risk for infants to develop overweight or obesity at age 2. In addition, the intervention was shown to have spillover effects in second-born children, even without further training for the parents. These were small studies. The population was primarily Caucasian, and this really needs to be replicated in more diverse populations and with larger groups. But I think we really need to have early and long-term prevention strategies to help kids from ever developing obesity in the first place.
Thank you. Well, in addition to these exciting results that both of you talked about in adults and in children and in obesity, and certainly moving towards personalized prevention and treatment efforts, what's next on the obesity research horizon? Dr. Reitman.
So I think what we have coming in obesity is that we really need more and better treatments. We have the GLP-1 agonists, which are the newest and possibly the best currently, but we really don't have an adequate pharmaceutical armamentarium. Other needs are to understand more of the mechanism of obesity. How do the different parts of the brain work together? So we sometimes talk about homeostatic and hedonic eating. Homeostatic, the eating just to maintain your body, the hedonic, that driven by reward behaviors. Those concepts are incredibly simplified, but on the other hand, they're very useful to think about different kinds of ways the brain may work. And I think that how the brain works is just a huge, only partially tapped area for future research. And the hope is that as we understand more about the pathways in the brain, that'll educate us better in figuring out how to treat obesity in a more directed way, whether it be with behavior, whether it be with drug, whether it be with diet, whatever. But obesity is the control of food intake and energy expenditure is driven by the brain, and we really need to understand that better.
Mm-hmm. Sue, your thoughts?
Sure. One of the things that I think we're increasingly thinking about is how to move beyond BMI as the be all and end all for obesity, for figuring out what your risk is, for figuring out what treatments to use, to really learn more about the heterogeneity of obesity, the different pathways through which people develop obesity or respond to treatment, as well as to better characterize the risk for complications based on more than numbers on a scale. Another challenge we face is really getting enough weight loss to have that impact on health. Studies have found that most people with obesity really seek weight losses of 15% or more of their initial weight, which is typically only attained with bariatric surgery. But the more weight you lose if you have obesity, the greater improvements in many of those obesity-related complications. So we have a need to develop more effective non-surgical therapies. One of the things we want to know is how can you get the beneficial effects of bariatric surgery without actually doing surgery, and understanding the underlying mechanisms by which bariatric surgery works. What's the impact on hormones, on bile acids, on the microbiome? This can help us to explore targeted therapies. In addition, I think it's an exciting time with the use of medications for obesity management. Obesity drugs are not used very much, and in part that's because of their checkered safety history over the years. But newer, safer, and more effective medications are being developed. We need to learn how and in whom we should use these drugs to really achieve the best outcome. And finally, I just want to mention a new study, Nutrition for Precision Health, that's going to be developing algorithms to predict individual responses to food and dietary routines, taking into account an individual's genes, gut microbes, and other lifestyle, biological, environmental, and social factors, so that we can help each person develop eating recommendations that improve health for them. Finally, I just want to talk a little bit about social determinants of health. These play such a significant role in obesity prevention and management. Through NIDDK funded research focused on health disparities, investigators aim to better understand the social determinants of health and address factors like access to health care, housing, safe spaces to exercise, and affordable nutritious food. And in fact, at NIDDK, we actually support a time sensitive mechanism to evaluate the effectiveness of new programs and policies that are designed to address obesity promoting behaviors and social determinants of health, like sugar sweetened beverage taxes, active transportation, like a new light rail system is being put in, changes in school start times to improve sleep, even universal basic income. And by allowing investigators to get in there early, collecting baseline data before the new policy is enacted, and then seeing the impact of that policy on the relevant outcomes, we can actually provide the evidence base to policymakers so they put their limited resource towards policies and programs most likely to have the desired effect.
Excellent. Good. Thanks. Here's a very frequent question that we've received, and it's unclear whether it's a definitional issue. But the question boils down to, what is intermittent fasting, and how does intermittent fasting differ from time-restricted feeding?
Yeah, that's something we're asked a lot. These are both considered time-based approaches to restricting caloric intake, and they're becoming popular approaches to weight loss. One of the most prominent approaches, as you said, is intermittent fasting. And intermittent fasting involves eating drastically fewer calories on a schedule, often 2 or 3 days a week. For example, a person might restrict their calories to 500 calories for 24 hours and then eat freely on the alternate days in a kind of every other day schedule. Or they might restrict their calories for 2 consecutive days and then eat what they'd like on the other 5. That's often called the 5-2 plan. Time-restricted feeding is a little bit different method to reduce overall caloric consumption. And time-restricted feeding limits the total hours a day dedicated to eating to about 8 to 10 hours a day. For example, a person might start eating at noon, stop eating any meals or snacks at 8, and then they're fasting the remainder of the hours.
Okay. Well, are intermittent fasting or time-restricted feeding effective? And what does the research say, if anything?
Yeah, well, they're popular, but the research isn't, the data aren't all in to say how effective they are. Because individuals approach intermittent fasting and time restricted feeding differently when they're not in that controlled clinical environment like a study, these types of weight loss strategies can actually be difficult to know how they're going to work in people out there in the free world. So again, with any weight loss strategy, I think we'd recommend that someone checks with their health care provider to see what they recommend. But early research outcomes seem to indicate that time-based approaches to caloric restriction could provide some metabolic benefits, at least in animal studies. You see that a lot. In studies of mice, time-restricted feeding has led to lower fat mass, plasma glucose, insulin, leptin levels, and improved glucose tolerance. The studies for humans are actually relatively mixed. And recently, there was a randomized controlled trial published in JAMA Internal Medicine looking at time-restricted eating and found that that did not affect weight loss. So I'd say that the research on intermittent fasting and time restricted feeding is still in early stages. And both NIDDK and other NIH institutes are currently funding both animal studies as well as studies in humans to learn more about these approaches to weight loss.
Thanks. Dr. Reitman, speaking about what does the research show, does technology like the use of cell phones and computers and the like, does that have an influence on obesity rates in children and adults?
I think the one to think of technology as a toolbox. So, for example, if you think of TV as a technology, if you correlate TV use with obesity, there's a correlation. The more TV you're watching, the more obesity there is. But on the other hand, if you think of computers and cell phones as technologies, they can be really useful. They can help a person monitor their food intake. They can provide virtual links to support groups. They can provide access to populations that aren't near providers or age groups that have more troubles getting out and to support groups or doctor's visits. And they can also promote awareness of this problem. So I think technology should be thought of as a tool, not as, and it can be detrimental, but I think we can figure out ways of using it to help people in many more ways that is detrimental, and therefore it's a very useful thing. We can use it to schedule activity. We can use it to monitor physical activity. Many of us have iPhones and know how many steps we took in a given day. And again, I think activity is important for metabolic health. It will have a small effect on obesity, but the bottom line for obesity per se is you want to eat less. But if in terms of following your physical activity towards metabolic health, then I think the iPhone or the Fitbit or whatever your particular device is a wonderful way of doing that. So I think technology can be put to really, really good use.
Thank you. Well, just to sort of riff a little bit off of what Dr. Reitman just mentioned, technology can obviously is a great tool in a general sense to measure calories in and conversely how much we're burning. And that's usually been how we've sort of summarized this, how much you're exercising, how much you're taking in. But, a third leg to that stool that people have come to recognize now is sleep. Sue, can you tell us a little bit about how does sleep affect obesity?
Sure. The connection may not really seem obvious, but research has shown that not getting enough sleep may contribute to weight gain. And there have been many epidemiologic studies, both in kids and adults, that show an association between short sleep and obesity. And in addition, both animal and human mechanistic studies have shown that sleep deprivation has a number of negative effects on appetite and metabolism that would increase susceptibility to obesity and type 2 diabetes. These are studies, for example, where they will bring people into a lab and actually sleep deprive them for a few days and measure what's happening, what they eat, what happens to their insulin resistance and other metabolic hormones. So one question has been, since we know that sleeping shorter sleep or low quality sleep is bad for you, could we actually get people to increase their sleep? And what would the effect be on food intake and body composition? But, until now, we haven't really had any good data that we can get people to increase their sleep just through behavioral means. But a small NIDDK-funded randomized controlled trial was just recently published in JAMA Internal Medicine. And they used a behavioral intervention to increase sleep in men and women with overweight. And the sleep extension group, this was short term, it was over 2 weeks, but they were able to increase sleep by more than 1 hour a night. And they had a decreased intake of 270 calories a day over the course of the study. And this was done by a gold standard method of doubly labeled water. So this is really a promising approach to obesity prevention. I think we need larger studies in diverse populations, and we need to look, as always, across the lifespan from kids to adults.
Mm-hmm. Sue, let me stick with you. We recently released the NIDDKY strategic plan. How does obesity research fit in to this plan that was just released?
Yeah, sure. The NIDDK strategic plan really covers everything from very basic science. What are the mechanisms by which obesity develops, through health disparities and social determinants of health? And I think it's really only by addressing everything from cells to society and doing research to understand the mechanisms, particularly in populations most affected by obesity, that we're going to come up with the effective prevention and treatment strategies to promote health.
Excellent. Good. Thank you. And Mark, one for you that we've gotten in from people with interest in this area. What is the right diet or healthy routine to prevent obesity?
So I wish there was a simple answer that would apply to everybody and we could all be satisfied and go home. But what I'd like to say is again, to stress that the goal of preventing obesity is to maintain metabolic health. Again, with obesity, is I think overemphasis on how we look, whereas really what we as physicians are really trying to do is prevent the comorbidities that the thing Sue mentioned, the diabetes, cardiovascular disease, stroke, heart attack, weight-bearing osteoarthritis, about 11 kinds of cancers, fatty liver, all those things. So you really want to prevent obesity. And how do you do it? Well, one thing is you can exercise, and exercise will have a modest effect on obesity, particularly if you're not obese to begin with. But it will improve your metabolic health out of proportion to any effect on body weight. And that's really something to stress. The other thing I like to say about the dietary intervention is it's the one that you will do and stick to and adopt and do long term. And that's the right diet for you. It's sort of an era of personalized medicine. Each individual has to figure out what they can do to maintain that reduced caloric intake, whether it's keeping a strict food diary, whether it's photographing every meal and trying to count the calories that they've eaten, whether it's following their physical activity more rigorously. So other than that, there's no one kind of right diet. It's the one that works for you. And works for you, I would define as reducing your caloric intake. Thank you.
Excellent. Thanks. Well, listen, before we close, I want to mention that we have information at niddk.nih.gov available in English and in Spanish that's free, and it's based upon the kinds of evidence that you've been hearing about today, and it covers really a range of topics for health that, again, Dr. Yanowski and Reitman have just discussed. And let me, having mentioned them, let me thank you again, Drs. Yanowski and Reitman, for joining me today to talk about obesity research supported by NIDDK that offers hope for the future. And thank you, all of you who are watching. We will post more information in the comments, and we'll watch for questions that we weren't able to answer during this event. If you have more questions after the event ends, comment on this video, and please visit niddk.nih.gov for more information about obesity prevention and treatment. Thank you. I'm Dr. Griffin Rogers. Thanks again for watching.